What if the Earth stopped spinning? Have you ever paused to think about Earth's silent, ceaseless spin? At roughly 1,000 miles per hour near the equator, this invisible motion shapes life on Earth in more ways than we usually realize. But what if, suddenly, Earth stopped spinning? This seemingly sci-fi scenario isn't just about losing our 24-hour day. It would trigger an unimaginable chain reaction of catastrophic events. From world-ending winds to desolate climate extremes, this hypothetical chaos provides a fascinating glimpse into the intricate balances that make Earth habitable. Let's break it down. Imagine Earth coming to a screeching halt. Although the ground beneath your feet would stop moving, everything not firmly attached to the bedrock, including oceans, the atmosphere, and even you, would continue moving at the same speed Earth had been spinning. For anything near the equator, that's 1,000 miles per hour. The results would be apocalyptic. Oceans would surge eastward into colossal tsunamis capable of engulfing entire coastlines. Coastal cities like New York, Tokyo, and Rio de Janeiro would vanish under these skyscraper-sized waves. In seconds, landmarks from mountains to rivers would undergo dramatic reshaping. Inland regions wouldn't fare much better. Winds, unleashed by the abrupt halt, could reach supersonic speeds, flattening everything in their path. Skyscrapers, forests, and vehicles would be swept up like autumn leaves in a gale. In essence, the world as we know it would dissolve into chaos, all within a matter of minutes. Surviving the immediate aftermath is only the beginning. One of the most profound changes would be the end of Earth's familiar 24-hour day and night cycle. Without its rotation, days and nights would stretch, lasting 6 months each. During the day, the side of Earth facing the sun would bake under ceaseless exposure. Temperatures would skyrocket, creating scorched, barren deserts in what were once fertile lands. On the other side of the planet, the prolonged night would plunge regions into unbroken darkness, resulting in freezing temperatures and lifeless ice fields. These extreme conditions would devastate ecosystems. Crops would struggle to grow in the absence of stable sunlight and temperature patterns. Plants depend on the balance between day and night, and their collapse would cascade into the destruction of the food chain. Humans, animals, and even bacteria would face challenges adapting to a world without a predictable cycle of light and dark. If Earth stopped spinning, its consequences wouldn't just stay on the surface. Earth's rotation powers its magnetic field, generated by the motion of molten iron in the planet's core. This field plays a crucial role in deflecting harmful solar wind and cosmic radiation. With no rotation, the magnetic field would slowly fade, leaving the planet exposed to lethal radiation. Over time, solar wind particles would strip away Earth's atmosphere, turning it into a dry, lifeless husk not unlike Mars. Without the atmosphere's protective layer, water on Earth's surface would eventually evaporate into space, making long-term survival impossible for most forms of life. Even after the initial chaos subsides, the planet's weather systems would remain in turmoil. Currently, Earth's rotation regulates the distribution of heat through the Coriolis effect, creating the patterns that steer winds and ocean currents. Without this effect, global weather would stabilize into two extremes. Hot, stagnant air would dominate the eternal daytime side of the planet, while frigid air would blanket the dark side. What's more, the oceans, no longer dragged into their characteristic currents by Earth's spin, would become motionless. Warm water once carried to colder regions by currents like the Gulf Stream would remain trapped, exacerbating temperature differences across the globe. The dynamics of weather would collapse into an equilibrium too harsh for most habitats to sustain life. The biggest challenge for life, including humanity, would be survival in such extreme conditions. Plants, the foundation of Earth's ecosystems, would be the first to suffer in regions that experience days or nights lasting half a year. Without reliable photosynthesis, food chains would disintegrate, leaving animals and humans struggling to find nourishment. Temperature stability, too, would pose a near insurmountable problem. On the scorched daytime side, the heat would render outdoor exposure unsafe. Meanwhile, settlements in the frigid nighttime zone would require advanced technology to generate heat and sustain farming in artificial conditions. Civilization as we know it would be forced to adapt or face extinction. Could humans survive such a world? It's possible. Underground shelters, advanced thermal technology, and artificial ecosystems could provide a lifeline. But adapting to a stationary Earth would come at the cost of unimaginable resources and engineering, a monumental shift in how humanity thrives on this planet. After the initial deaths of many species, life on Earth might slowly adapt, albeit in vastly reduced forms. Evolutionary processes could favor creatures that survive under extreme heat or unrelenting cold. For example, organisms resembling microbes found near volcanic oceanic vents, capable of withstanding intense heat, could flourish on the eternal daytime side of Earth. Conversely, certain hardy Arctic species might thrive in the freezing conditions of perpetual night. Over time, Earth's biosphere might stabilize into isolated ecosystems around narrow border zones, the twilight bands, where daylight and darkness overlap, creating habitable conditions. These regions could sustain ecosystems similar to Earth's polar regions, adapted for extremes but capable of supporting limited forms of life. Interestingly, this thought experiment can teach us about other planets in our universe. Many exoplanets discovered by astronomers are tidally locked to their stars, meaning one side always faces the star while the other remains in darkness, much like what Earth would become if it stopped spinning. Learning how Earth might respond to this state offers insight into the conditions on such alien worlds. Understanding the long-term climate, weather systems, and potential for life on these tidally locked planets could inform future space exploration. Could similar twilight zones on exoplanets harbor life? How might intelligent species adapt to such extreme environments? Earth's hypothetical stationary state could mirror the challenges of sustaining life on other astronomical bodies. This hypothetical scenario underscores the intricate systems that sustain life on Earth. From our rotation-driven magnetic field to the carefully balanced day-night cycle, Earth is a masterpiece of interconnected forces working together. Stopping its spin would unravel everything we take for granted. So, why delve into such a catastrophic what-if? These scenarios, though fictional, help us better appreciate the fragile balance of forces at play. They highlight Earth's uniqueness as a life-supporting planet and remind us of the delicate checks and balances that operate beneath our feet. Ultimately, the hypothetical halt of Earth's rotation serves as a humbling reminder of how much we owe to forces we often overlook. The seemingly mundane rotation of the planet governs our day and night, stabilizes our climate, and protects us from the sun's hostility. Without it, our world and existence would unravel in more ways than we could comprehend. This speculative journey into a stationary Earth is more than just an exploration of planetary disasters. It's an invitation to marvel at the hidden mechanisms driving life and prosperity on this blue dot we call home. Perhaps, in contemplating this scenario, we can better appreciate the intricate systems that make Earth such a remarkable place to inhabit.